Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a question that feels almost too large to hold in a single thought. The possibility that our entire universe may exist inside something far stranger than we ever imagined, a black hole. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable, and when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey together. And if your mind begins to wander, that's perfectly fine, let it drift. We'll still be here, quietly unfolding the story. For most of your life, you may have carried a simple picture of the universe, a beginning, a long time ago, a vast expansion, galaxies drifting apart like islands in a silent ocean. It's a story we've been told many times. The universe began with a great expansion, what we call the Big Bang, and everything we see today slowly formed from that moment. It is a beautiful story, clean, complete, comforting even. But as scientists have looked closer and deeper, that story has begun to soften at the edges, because when you follow the equations far enough, when you look at the most extreme places in the universe, something unusual begins to appear. Not a contradiction exactly, but a quiet suggestion that something may be missing, and that something may change everything. Black holes are often described as the most mysterious objects in the cosmos, regions where gravity becomes so strong that not even light can escape, places where space bends and time itself begins to slow. But what makes them truly fascinating is not just their power, it is what they do to our understanding of reality. Near a black hole, time does not behave the way you expect. If you were to watch someone drift toward one from a safe distance, you would see them slow down, gradually, gently, as though time itself was stretching like soft fabric. Their movements would become slower and slower until they seemed almost frozen at the edge. And yet, from their own perspective, nothing unusual would happen at first. Their clock would tick normally, their thoughts would flow as always. They would continue forward, unaware of how differently they appear to you. Two observers, two experiences of time, both real. And already something about reality begins to feel less solid than it once did. Now imagine taking this idea further. Imagine a region of space so curved, so deeply shaped by gravity, that it forms a kind of boundary, a horizon, a point beyond which nothing returns, not because there is a wall, but because the structure of space itself has changed in such a way that all paths lead inward. This boundary is called the event horizon. Though the name sounds technical, you can think of it simply as a kind of one-way threshold, a place where the future only points in one direction, inward, and at the centre, or perhaps more accurately, at the deepest part of this structure, lies something we do not fully understand, a region where our current theories fall silent, where the familiar ideas of space and time no longer behave in ways we can describe with confidence. Some call it a singularity, but that word is less a description and more an admission. It tells us that we have reached the edge of our understanding, and it is here, at this edge, that a quiet question begins to emerge. What if these strange objects are not just isolated features of the universe? What if they are something more fundamental? Over the past few decades, a small but growing number of physicists have begun to explore an idea that once sounded almost impossible. The idea that a black hole might not just be an object inside a universe, but that it could be the beginning of one. that what we perceive as a Big Bang, the moment our universe came into existence, might instead be the inner unfolding of a much larger structure. A structure that, from another perspective, would look like the formation of a black hole. In this view, the universe does not begin with an explosion into empty space. Instead, it begins as a transition, a passage, a shift from one region of reality into another. And if that is true, then the universe you're in right now, the room around you, the quiet air, the steady rhythm of your breathing, all of it may exist within a space that, from the outside, would look like something else entirely. A black hole. It is a strange thought, perhaps even unsettling at first. But if you sit with it gently, without trying to resolve it too quickly, it begins to feel less like a contradiction and more like an invitation to see reality not as a fixed, solid structure, but as something layered, something that depends on perspective, something that reveals different truths depending on where and how you look. And tonight, as we drift further into this idea, we will not rush toward answers. Instead, we will move slowly, step by step, like walking through a quiet landscape at dusk, allowing each idea to settle, to unfold, to find its place. Because the story of black holes is not just about gravity or distant galaxies. It is about the nature of reality itself, and perhaps, in a quiet way, it is also about where we are and what kind of universe we truly inhabit. As this thought settles softly in your mind, like a distant echo, we can begin to look more closely at what a black hole really is, not as a symbol of mystery, but as a structure we can gently understand, piece by piece. And as we do, the picture may begin to change in ways that feel both surprising and strangely familiar. As that quiet idea begins to settle, we can take a gentle step closer and begin to understand what a black hole really is, not as something frightening or destructive, but as something deeply woven into the fabric of the universe. At first glance, the word itself can feel heavy. A black hole sounds like an empty void, a place where things disappear. But in truth, it is not a hole in the way we might imagine. It is not a tear, or a gap, or an absence. It is instead a place where space itself has been shaped, curved, and drawn inward by gravity. To understand this, it helps to picture something simple. Imagine a soft, stretched surface, like a sheet pulled gently at the corners. If you place a small object on it, perhaps a marble, the surface barely changes. But if you place something heavier, like a bowling ball, the surface dips. It curves inward. Now, if you roll a marble nearby, it will begin to move toward that dip, not because something is pulling it directly, but because the surface itself is guiding its path. This is a simple way of imagining gravity, not as a force reaching out, but as a shape that things naturally follow. And a black hole is what happens when that curve becomes so deep, so steep, that all paths lead inward, even light. Light, which normally travels faster than anything else we know, begins to follow this curve as well. And as the curve becomes steeper, even light can no longer find a path that leads outward. It simply continues inward, along the only paths that remain. And so, from the outside, the region appears completely dark. Not because it is empty, but because nothing escapes to tell us what is inside. At the edge of this region lies something we mentioned before, the event horizon. You can think of it as a quiet boundary, not a surface you could touch, not a wall you could feel, but a point in space where the geometry, the shape of reality, changes in a subtle but profound way. Outside this boundary, it is still possible to move freely, to turn around, to escape. But once you cross it, every possible direction leads further inward, not because you're being pulled in the way we usually think, but because the structure of space itself no longer allows any other path. It is a gentle idea, but also a powerful one, because it suggests that the universe is not just a stage where things happen, but something that shapes those happenings at the deepest level. Now, as you move closer to this boundary, something else begins to happen. Time itself begins to slow. From the perspective of someone far away, a clock near a black hole would appear to tick more slowly, not dramatically at first, but gradually, subtly, like a rhythm stretching out, second by second, becoming longer, softer, more spaced apart. And as you approach the edge, this slowing becomes more and more noticeable. From the outside, it would seem as though time is gently fading, as if each moment is being stretched thinner and thinner until it almost comes to a pause. But if you were the one near the black hole, you would not feel this change in the same way. Your own clock would seem normal, your heartbeat steady, your thoughts flowing as they always have. And this is where the picture becomes quietly fascinating, because it reveals that time is not something fixed, not something universal. It is something that can flow differently, depending on where you are. Two observers, each experiencing their own version of time, both equally real. And already, the universe begins to feel less like a single, shared story, and more like overlapping perspectives, gently layered together. As we continue inward in our imagination toward the deeper regions of a black hole, we arrive at something even more mysterious, the center, or what we call the singularity. It is often described as a point where everything is compressed, where density becomes infinitely large, where the known laws of physics no longer behave in ways we can predict. But rather than thinking of it as a literal point, it may be more helpful to think of it as a place where our current understanding reaches its limit, a place where our equations, our models, our carefully built descriptions begin to lose their clarity, not because reality itself has broken, but because we have reached the edge of the tools we use to describe it. Some newer ideas suggest that this center may not be an infinite point at all. Instead, it could be something more subtle, a region where matter becomes extremely compressed, but not infinitely so, where space and time begin to shift into forms we do not yet fully understand, but that remain part of a deeper, consistent structure. In these views, the black hole is not a final destination. It is a transformation, a place where familiar rules give way to something new, something still waiting to be fully understood, and perhaps something that connects to larger structures beyond our current view. But for now, we don't need to resolve that mystery. It is enough to simply sit with the idea, to imagine a place where space curves so deeply that even light follows it inward, where time flows at different rhythms depending on your perspective, and where the center remains hidden, not because it is unreachable, but because it lies beyond what we can currently describe. And as you hold that image gently in your mind, you may begin to notice something else, that black holes are not isolated. They are not rare exceptions. They exist throughout the universe, quietly, steadily, shaping the galaxies around them. And as we continue this journey, we will begin to see how these silent structures, far from being mere curiosities, may play a central role in the story of everything we see, from the slow formation of stars to the vast architecture of galaxies, and perhaps to the very structure of the universe itself. As you begin to picture a black hole in your mind, something curved, quiet, and quietly powerful, your view can begin to expand outward, because black holes are not only found in distant, isolated corners of space, they are almost everywhere. And more importantly, they are not alone. If you could slowly drift outward, beyond the scale of a single star, beyond even the boundaries of a solar system, you would begin to see something remarkable. Galaxies, vast collections of stars, hundreds of billions of them, arranged in delicate spirals, soft ellipses, or scattered clusters. From afar, they resemble glowing islands, floating in an ocean of darkness, and at the centre of nearly every one of these galaxies lies something unexpected, a black hole, not a small one, but something far more immense. These are called supermassive black holes. Their mass can be millions, or even billions, of times greater than our Sun. And yet, despite this enormous presence, they remain almost completely invisible, quiet, hidden, but never insignificant. At the centre of our own galaxy, the Milky Way, there is such an object, a supermassive black hole known as Sagittarius, a star. Though it is far too distant to see directly with the naked eye, its presence is unmistakable. We know it is there because of the way stars move around it. Stars near the centre of the galaxy do not wander randomly. They follow precise curved paths, orbiting something unseen. And by carefully observing these motions over time, scientists have been able to infer the existence of a massive object, holding everything together, like leaves circling a quiet whirlpool, invisible beneath the surface. And this is where our understanding begins to shift, because black holes are often imagined as cosmic destroyers, endlessly consuming anything that comes too close. But when you step back and look at the larger structure of a galaxy, a different picture begins to emerge. These black holes are not simply consuming matter, they are shaping it. Around a supermassive black hole, gas and dust do not fall straight inward. Instead, they form a vast rotating structure, a glowing disk that slowly spirals toward the centre. You might imagine it like water circling a drain, but stretched across distances so large that light itself takes years to cross them. As this material moves inward, it begins to heat up, gently at first, then more intensely, until it glows with incredible brightness. Not because the black hole itself emits light, but because the journey toward it releases energy, a quiet transformation of motion into warmth and then into light. And sometimes, something even more remarkable happens. From the regions near the centre, powerful streams of energy emerge, shooting outward in opposite directions. These streams, often called jets, can travel vast distances stretching far beyond the galaxy itself. They move not slowly, but at speeds approaching that of light. Yet even here, there is no need to imagine violence. Instead, you might picture something more like a gentle but persistent wind, shaping the environment around it over long stretches of time. These streams interact with the gas spread throughout the galaxy. They can push it, compress it, or disperse it, and in doing so, they influence something deeply important: the birth of stars. Stars form when clouds of gas and dust slowly collapse under their own gravity. But this process is delicate. Too much pressure, and the cloud is blown apart. Too little, and it never begins to form. And this is where the black hole's influence becomes subtle and profound. By sending out energy into its surroundings, the black hole can regulate this process. In some regions, it may gently compress gas, helping stars to form. In others, it may disperse material, preventing new stars from emerging. A balance, not intentional, not guided, but arising naturally from the structure of the system. And over time, this balance shapes the entire galaxy. It determines how many stars are born, where they appear, and how the galaxy evolves across millions, even billions of years. Without this influence, galaxies might grow too quickly, or collapse too chaotically, or fail to organize at all. In this way, the black hole at the center is not merely an object. It is a kind of anchor, a quiet presence, around which the rest of the galaxy finds its rhythm. And if you follow this idea a little further, something even more interesting begins to appear. There seems to be a relationship, a gentle correlation, between the size of a galaxy and the mass of its central black hole. Larger galaxies tend to host larger black holes, smaller galaxies, smaller ones, as though they are growing together, evolving in tandem, each influencing the other in ways we're only beginning to understand. It is not a simple cause and effect relationship. It is something more intertwined, a co-evolution, a shared story unfolding over immense stretches of time. And so the image of the black hole begins to change, no longer just a point of disappearance, but a center of organization, a participant in the life of a galaxy, quietly shaping, guiding, influencing, without ever needing to be seen directly. And if black holes play such a role in galaxies, structures that themselves contain hundreds of billions of stars, then it is natural to wonder, what role might they play on even larger scales? Could these same structures, these same patterns of influence, extend beyond galaxies into the fabric of the universe itself? Could something that shapes stars and dust and light also play a role in shaping reality at its deepest level? We do not yet have complete answers, but as we continue this journey, we will begin to explore how these quiet giants, hidden at the centers of galaxies, may connect to ideas far larger than we once imagined, ideas about the origin of the universe, the nature of space and time, and the possibility that what we call our universe may itself be part of something even greater. As black holes begin to feel less distant and more quietly familiar, we can follow their story into a more active phase, a time when these silent structures begin to shine with unexpected intensity. There are moments in the life of a galaxy when its center does not remain calm. Instead, it begins to shine, not gently, but with an intensity that can outshine all the stars within the galaxy itself. These extraordinary objects are known as quasars. You can think of a quasar as a galaxy whose center has awakened, where the black hole at its core is actively drawing in large amounts of gas and dust. As this material spirals inward, it does not fall quietly. It gathers, it accelerates, and it begins to glow. The light produced in this process can travel across billions of light years, reaching us as faint but persistent signals from the distant past. In fact, many of the brightest points we see in the deep universe are not stars at all, but these active galactic centers, quasars, and yet, despite their brightness, they are not chaotic explosions. They are structured, ordered. The material around the black hole forms a wide, flattened disk, rotating steadily, layer by layer, like a vast cosmic whirlpool. As it moves inward, friction builds, energy is released, light emerges, not all at once but continuously, like a steady flame. And in this light, we begin to see a new aspect of black holes, not only as shapers of galaxies, but as sources of transformation. Now, in the earlier stages of a galaxy's life, things are not always clear. The center is often surrounded by thick clouds of dust and gas. These clouds obscure the light, making it difficult to see what is happening within. This stage is sometimes referred to as a red quasar phase, not because the object itself is red, but because the dust filters the light allowing only longer, softer wavelengths to pass through. The brightness is still there, but it is hidden, veiled, like a distant lantern seen through fog. This phase represents a kind of beginning, a time when the black hole is actively growing, gathering material, shaping its environment, but not yet fully visible. And then, slowly, something changes. As the black hole continues to feed, it also releases energy outward. Gentle but persistent streams of radiation and motion begin to push against the surrounding dust. Not violently, but steadily, like a breeze clearing mist from a quiet valley. Over time, this process begins to open up the center of the galaxy. The dust thins, the view becomes clearer, and the light, once hidden, begins to shine more directly. This is the transition into what we call a blue quasar phase. Here, the brightness is no longer obscured. The galaxy's center becomes one of the most luminous objects in the universe. The black hole, though still invisible itself, is now revealed through the energy of everything moving around it. And yet, this phase does not last forever. Eventually, the supply of nearby gas begins to diminish. The surrounding environment becomes more stable. The intense activity slowly fades. The galaxy settles, and the quasar becomes quiet once again. What remains is a more mature galaxy, one that has passed through a period of intense transformation, guided in large part by the presence of its central black hole. If you step back and look at this process as a whole, it begins to resemble something familiar, a cycle, a beginning, a peak, and a gentle settling. Not unlike the life of a star, or the changing of seasons, and within this cycle, black holes are not simply passive objects, they are participants. They influence how galaxies grow, how they evolve, and how they eventually find balance. In a way, you might think of quasars as the youth of galaxies, a time of brightness, energy, and rapid change. And as the galaxy ages, it becomes calmer, more stable, its central black hole still present, but no longer as visibly active. This perspective adds another layer to our understanding, because it suggests that black holes are not separate from the story of the universe. They are deeply embedded within it. They grow with galaxies, evolve with them, and help guide their development over immense stretches of time. And as we continue to explore this idea, another question begins to form, gently, almost unnoticed. If black holes can shape galaxies in such profound ways, if they can influence the formation of stars, the distribution of matter, and the overall structure of these vast systems, then what role might they play at even larger scales? Could the same principles, the same quiet processes, extend beyond galaxies, beyond clusters, into the very structure of the universe itself? It is a question that does not demand an immediate answer. It simply lingers, and as it does, we can turn our attention to something even more subtle, something that exists in the spaces between stars, between galaxies, and even within ourselves. Dust, tiny particles, drifting quietly through space, carrying with them the building blocks of everything we know. Because to understand how galaxies evolve and how black holes influence them, we must also understand the role of this seemingly simple but profoundly important material. Instead of fading away completely, the bright phase of galaxies softens, and as the intense glow of quasars settles into a quieter rhythm, what remains may seem at first almost insignificant. A thin scattering of particles, tiny grains, drifting through space, dust. It is easy to overlook something so small. On Earth, dust gathers quietly on forgotten surfaces, carried by air, unnoticed until it catches the light. But in the universe, dust is not something left behind. It is something essential. These tiny particles are formed in the final stages of stars. When large stars reach the end of their lives, they expand, cool, and gently release their outer layers into space. In other moments, more dramatic endings occur, where stars collapse and release vast amounts of energy, sending material outward in expanding clouds. Over time, this material cools, settles, and forms microscopic grains: carbon, silicon, oxygen, simple elements shaped into delicate structures, floating in the quiet between stars. If you could hold one of these grains, though it would be far too small to see, you would be touching something ancient, something that may have formed billions of years ago in the fading light of a distant star. And slowly, very slowly, these grains begin to gather, not quickly, not all at once, but through gentle interactions. They drift closer, they collide softly, they begin to stick. Clouds begin to form, large, diffuse regions of gas and dust spreading across light years of space. Within these clouds, something remarkable begins to happen. Gravity, the same quiet shaping force we have already encountered, begins to draw the material inward. Regions of slightly higher density pull in more matter, becoming denser still, until eventually the cloud begins to collapse. But this collapse is not chaotic. It is balanced, delicate, almost hesitant. Too much outward pressure, and the cloud disperses. Too little, and nothing happens at all. But when the balance is just right, a new star is born. At the center of the collapsing cloud, temperature rises, pressure increases, and eventually the core becomes hot enough for a new kind of process to begin, one that releases energy not from motion, but from the transformation of matter itself. A star ignites, gently at first, then steadily, becoming a new source of light in the vast darkness. And around this newborn star, something else begins to form. The remaining dust and gas, instead of falling directly into the star, spreads out into a thin, rotating disk. Within this disk, particles continue to collide, to stick, to grow. Grain by grain, fragment by fragment, small structures emerge. Over time, these structures become larger: pebbles, rocks, eventually, entire worlds, planets. And on at least one of those worlds, in a quiet corner of a galaxy, under the steady light of a star, something even more delicate begins to unfold. Life. It is a slow story, a patient one, and it begins not with something grand, but with dust. Now, if we step back slightly, we begin to see how this process connects to everything we've explored so far. Black holes, those quiet centers of galaxies, influence how gas moves, how it gathers, how it spreads. Through their subtle feedback, those gentle streams of energy we spoke of, they can compress clouds in some regions, encouraging the birth of stars. In other regions, they can disperse material, slowing or preventing that process. They do not create stars directly, but they shape the conditions under which stars can form. And because stars are the origin of dust, and dust is the origin of planets, and planets are the stage upon which life can emerge, the influence of black holes reaches further than it might first appear, in a very real sense that they help shape the possibility of life itself, not deliberately, not with intention, but as part of the natural unfolding of the universe. And so, the picture becomes richer. Black holes are no longer just distant curiosities, or extreme objects at the edge of understanding. They are woven into the quiet processes that lead step by step from simple particles to complex structures to living systems, from dust to stars to life, and perhaps even to consciousness. There is something quietly humbling in this realization that the atoms in your body, the air you breathe, the ground beneath you, all began as part of this long, gentle cycle. Stars forming, stars fading, dust drifting. And within that cycle, black holes playing their quiet role, shaping the flow, guiding the balance, without ever needing to be seen directly. As you sit with this idea, you might begin to feel a sense of connection, not in a dramatic way, but in a subtle one, a sense that the story of the universe is not separate from your own, that the processes unfolding across billions of years and across unimaginable distances have in some quiet way led to this moment, this breath, this awareness. And as that thought settles softly, like dust in still air, we can begin to look more closely at another aspect of this delicate balance, the way black holes not only support creation, but also gently limit it. The push and the pull, the shaping of galaxies not just through growth, but through restraint, a quiet balance that continues to unfold across the universe, even now. With this quiet journey from dust to star still lingering in your mind, we can now turn to something that feels, at first, almost like a contradiction. Because while black holes help create the conditions for stars to form, they also gently prevent them, not in a harsh or chaotic way, but through a subtle balance, a push and a pull. If you imagine a galaxy as a vast, slowly evolving ecosystem, then the black hole at its centre is not simply an object sitting still. It is active, not constantly, not violently, but in long, gradual phases that unfold over millions of years. At times, the black hole draws in surrounding gas and dust. This inward flow forms the glowing disk we spoke about earlier, where material spirals closer and closer, releasing energy as it moves. And as this process continues, some of that energy does not remain near the centre. It travels outward, in the form of radiation and in the form of those long, narrow streams we gently described before, stretching away from the galaxy's core. You might imagine them not as bursts, but as steady currents, like a wind that flows through the structure of the galaxy, interacting with everything it touches. Now, this outward flow has an interesting effect. In some regions, it compresses gas clouds, gently pushing them closer together. When this happens, the clouds can become dense enough to begin collapsing under their own gravity, leading to the formation of new stars. In this way, the black hole, indirectly, encourages creation. But in other regions, the same outward energy has the opposite effect. Instead of compressing the gas, it disperses it. It spreads the material thin, making it more difficult for gravity to gather it back together. And in those regions, star formation slows, or even stops. So within the same galaxy, the same central process can both create and limit. It is not a contradiction. It is a balance, a natural regulation that prevents the galaxy from evolving too quickly, or becoming unstable. If stars formed everywhere, all at once, the galaxy might burn through its available material too rapidly. If no stars formed at all, it would remain dark and quiet. But through this gentle interplay, the galaxy finds a rhythm, a pace that allows it to evolve over vast stretches of time, and this process is often described as feedback, not in the sense of intention or control, but as a loop. The black hole influences its surroundings, and those surroundings, in turn, influence how the black hole continues to evolve. A quiet exchange. Now, there are moments when this balance becomes more noticeable. Occasionally, a star may wander too close to the center, drifting into the region where the black hole's influence becomes overwhelming. As it approaches, the difference in gravitational pull between one side of the star and the other begins to grow, gently at first, then more strongly, until the star begins to stretch, not abruptly, but gradually, as though it were being pulled into a long, thin stream. This process is sometimes described with a vivid name, but we can simply think of it as a kind of unraveling. The star's material spreads out, forming a stream of gas that spirals toward the center, joining the rotating disk, and as this material settles, it releases energy, briefly increasing the brightness of the region. A soft flare, a momentary glow before the system returns to its quieter state. Even here, what might seem like destruction becomes part of a larger cycle. The material from the star is not lost, it is redistributed, transformed, contributing to the ongoing evolution of the galaxy. And this idea that nothing is truly wasted begins to appear again. Matter changes form, energy moves, structures evolve, but the underlying story continues. If you step back once more and look at the galaxy as a whole, this push and pull becomes almost like breathing. Inward, outward, gathering, releasing, creation, and gentle restraint. Not opposing forces, but complementary ones. And over time, this rhythm shapes the entire structure. It influences how dense the galaxy becomes, how many stars it contains, how its light spreads across space. It even affects how galaxies interact with one another, how they merge, how they grow. All of this, guided in part by the quiet activity of something we cannot see directly, a black hole. And as you sit with this idea, you may begin to notice something subtle, that the universe, at every scale we have explored so far, seems to favor balance, not extremes, not endless growth or complete stillness, but a gentle middle ground, where processes regulate themselves, where structures emerge, stabilize, and evolve. And if this pattern holds true, not just for stars and galaxies, but for deeper layers of reality, then perhaps the behavior of black holes is not an exception, but a clue, a glimpse into how the universe organizes itself, even at its most extreme edges. And as we continue this quiet exploration, we will begin to move closer to those edges, not physically, but conceptually, toward the experience of what it might feel like to drift near one of these boundaries, to approach a place where time changes, where space curves more deeply, and where the familiar structure of reality begins to soften. A place where, if we imagine gently enough, we might begin to sense what lies beyond. As that delicate balance within galaxies drifts gently into the background, your perspective can begin to shift, not outward into larger structures, but inward, toward experience. Imagine for a moment that you're no longer observing the universe from afar, but drifting within it, not moving quickly, not falling in any sudden way, but slowly, almost weightlessly, carried along by something you cannot quite feel. Ahead of you, there is a region of space that looks no different from its surroundings. No sharp edge, no visible boundary, just darkness, slightly deeper than the rest. This is how a black hole first appears, not as a hole, but as a subtle absence of light. As you drift closer, the stars behind it begin to change. Their positions seem to shift, not abruptly, but gently, as though their light is being bent around something unseen. The sky itself begins to curve. It is not something you would notice all at once. It happens slowly, almost like watching reflections ripple across water, and still, There is no sense of danger, no sudden pull, only a quiet change in how space behaves around you. If someone were watching you from far away, from a safe distance, they would begin to notice something unusual. Your movement would appear to slow. At first, only slightly. Your gestures would take a little longer. Your motion would stretch, becoming more gradual, as though time itself were softening around you. To them, it would seem as though you are gently easing towards stillness, not stopping completely, but approaching it. And as you draw nearer to the boundary we spoke of earlier, that invisible threshold, this effect becomes more pronounced. From their perspective, your time begins to stretch further and further, each second taking longer to pass, until eventually you seem almost frozen in place, a quiet image, suspended at the edge, and yet, from where you are, nothing feels unusual. Your breathing remains steady, your thoughts continue, one after another, flowing naturally. If you were holding a clock, it would tick as it always has, second by second, evenly, calmly. There is no sensation of slowing, no indication that anything has changed. And this is where the experience becomes quietly fascinating, because two different views of the same moment now exist. From the outside, time is stretching. From the inside, time flows normally, like two clocks, sitting side by side, yet somehow disagreeing. Neither one wrong, both simply following the structure of the space they inhabit. As you continue drifting, you approach the event horizon. Though you cannot see it, you might sense a subtle shift. Not a barrier, but a transition. A place where all possible paths, all directions you could move, begin to lead inward. Even if you tried to turn away, there would be no path that truly leads back out. Not because you're being held, but because the shape of space itself has changed. It is a gentle realization, almost like noticing that a road you are walking on slowly curves in a direction you hadn't expected, until eventually, there is no longer a way to retrace your steps, and as you pass this unseen boundary, something important happens, but it is not something you would feel. There is no sudden jolt, no dramatic shift. You simply continue, drifting, as you always have. Behind you, the outside universe fades, not abruptly, but gradually, like a memory becoming less distinct. And ahead, there is only the inward journey. From the perspective of the distant observer, you never quite cross this boundary. You remain there, suspended, your image slowly dimming, fading into the surrounding darkness. But from your own perspective, you have already moved beyond it. Two realities, gently overlapping, yet never fully aligning. And as you move deeper, something else begins to change. The light around you behaves differently, not vanishing, but stretching. Colours shift subtly, becoming softer, longer, as though the light itself is being gently pulled along the same inward path. If you looked outward, toward the universe you came from, you might see it compressed into a smaller and smaller region of your view, the vastness of galaxies, slowly folding into a distant glow, not disappearing, but becoming more concentrated, more distant, and still. Your experience remains calm. There is no rushing, no sense of falling faster, only a steady continuation, a quiet movement forward into a region where familiar ideas begin to soften. And perhaps, as you sit with this imagined journey, you begin to notice something subtle, that what we call falling is not quite the right word. Because falling suggests speed, it suggests urgency. But here, it feels more like being carried, like drifting along a current that does not push, but simply guides. And in this way, the experience becomes less about motion and more about direction. Not how fast you're moving, but where all paths now lead. Forward, always forward. And if that is true, then something quietly profound begins to emerge. That moving deeper into a black hole may not just be movement through space, but movement through time. That what feels like drifting inward may also be a journey into the future, one that cannot be paused or reversed. A gentle unfolding, a path that continues, no matter what. And as this idea begins to take shape, we can allow ourselves to explore it more carefully, to understand how time itself begins to change, not just in how it appears, but in how it is structured. Because in these deeper regions, the distinction between space and time begins to blur, and what once felt separate may begin to merge in ways that are both subtle and deeply transformative. As that quiet sense of drifting continues, something even more subtle begins to unfold. At first, it is almost impossible to notice. Nothing around you appears to suddenly change. There is no clear boundary, no moment where one state ends and another begins, and yet, the deeper you move, the more the structure of reality itself begins to shift. Earlier, we gently explored how time can flow differently depending on where you are, how two observers can experience the same moment and yet measure it in different ways. Now, we take one more step, because inside a black hole, time does not just slow down, it begins to change its role. To understand this, it helps to return to something familiar. In everyday life, you can choose where to move in space. You can walk forward, turn around, step to the side. Space offers you freedom in many directions, but time feels different. You do not choose to move through time. It carries you, always forward, from one moment to the next. Even if you remain completely still, time continues. Now imagine that this distinction begins to soften, that the direction you are moving inward, deeper into the black hole, is no longer just a direction in space. It becomes something more like time itself, a path you cannot turn away from, a direction that is no longer optional. As you continue drifting inward, every possible path, every direction available to you, leads further along this inward journey. Not because you are being pulled in a forceful way, but because the structure of reality has changed. In the same way that you cannot step backward in time, you cannot move outward in this region. The inward direction becomes your future. It is a quiet shift in perspective, but a profound one, because it suggests that space and time, which once felt like separate aspects of reality, begin to merge, to exchange roles, in a way that is difficult to picture, but possible to feel. You're no longer simply moving through space, you're moving along a path that resembles time, steady, unavoidable, continuous, and still, the experience remains calm. There is no sense of acceleration, no rushing toward a destination, only a gentle unfolding, one moment flowing into the next, as it always has. But beneath that calm surface, something deeper is happening. The structure of your surroundings, the way distances are measured, the way light behaves, all begin to adapt to this new configuration. If you could observe your own shape from the outside, something else might appear. The difference in gravitational influence between one part of your body and another becomes more noticeable, not suddenly, not violently, but gradually. Imagine holding a soft piece of fabric and gently pulling at each end. It stretches slowly, evenly, becoming longer and thinner. In a similar way, objects moving deeper into a black hole begin to experience a stretching effect, not as a sharp event, but as a continuous transformation, a gentle elongation, guided by the changing structure of space. But from your own perspective, this process would not feel dramatic. Your immediate surroundings would remain familiar, your sense of self intact. Because everything around you, including the very space you occupy, is undergoing the same transformation. There is no single moment where you would say, "This is where it changes." It is simply different, gradually, quietly, and as you continue along this inward path, something else begins to shift, your connection to the outside universe. If you were to look back toward the stars, toward the galaxies you once saw spread across the sky, you would notice them becoming more distant, not in space, but in access. The light reaching you would carry information from earlier and earlier moments, as though you were seeing the past unfolding all at once, a condensed history, gently folding into your view, and eventually, even that connection begins to fade, not abruptly, but softly, like a sound growing quieter as it moves farther away, and in its place, there's only the continuation of your inward journey. At this stage, it becomes clear that what you're experiencing is not simply motion through a region of space, it is something deeper, a transformation of how space and time are arranged, a reordering of the framework that defines direction, movement, and change. And this leads us to a quiet insight, that what we call falling into a black hole may not be falling at all. It may be closer to moving forward along a path that has become your only future, a path where turning around is no longer meaningful, because the concept of back has lost its structure, only forward remains, and yet this is not a loss. It is simply a different way of existing within the same underlying reality, one that follows its own rules, its own geometry, its own quiet logic. And as we allow this idea to settle, gently, without forcing it into clarity, we begin to approach something even more profound. Because if space and time can change roles, if the structure of reality can shift in such a fundamental way, then what lies at the center of this process may not be what we once imagined, not a point of infinite collapse, but something else. Something that does not mark the end of the journey, but perhaps a transition into something new. And as this possibility begins to take shape, we can move one step closer to the place where our current understanding begins to fade and something deeper quietly begins to emerge. Gradually, as the inward journey deepens, and the distinction between space and time becomes more fluid, we arrive at a place that is difficult to describe, not because it is hidden, but because it lies at the edge of what our current understanding can clearly explain. This is the region often referred to as the center of a black hole, and for a long time it has been described in a very specific way, a singularity, a point where everything collapses inward, where density becomes infinitely large, where the known laws of physics no longer behave in ways we can predict. It is a powerful idea, but also a fragile one. Because when scientists say infinite, it often does not mean that something truly becomes endless. It means that our equations, the mathematical tools we use to describe reality, have reached a point where they no longer give meaningful answers. It is not necessarily a statement about what exists, it is a statement about what we do not yet understand. So instead of imagining this center as a literal point of infinite compression, it may be more helpful to think of it as a place where our current picture becomes incomplete, a place where two different descriptions of the universe, both successful in their own domains, begin to disagree. On one hand, we have the theory that describes gravity as the gentle curvature of space and time. It works beautifully for large structures, for stars, planets, and galaxies. On the other hand, we have the theory that describes the smallest scales, where particles behave in ways that are subtle, probabilistic, and deeply interconnected. Individually, these descriptions are remarkably accurate, but at the center of a black hole, they begin to overlap, and when they do, their predictions no longer align. It is as though two different maps of the same landscape, drawn at different scales, begin to contradict each other when you try to place them together, and so the idea of a singularity becomes less of a destination and more of a signal, a sign that we are missing something deeper. In recent years, some new ideas have begun to emerge. They suggest that instead of collapsing into an infinitely small point, matter may reach a state of extreme compression and then undergo a subtle transformation. Not an explosion in the usual sense, but a kind of release, a gentle rebound. You might imagine pressing down on a soft surface, slowly, steadily, until it can no longer compress further. At that point, it does not disappear. It pushes back, not violently, but inevitably. In a similar way, some models propose that at the deepest levels, space itself resists being compressed beyond a certain limit, and when that limit is reached, the inward collapse may transition into an outward expansion, a bounce. In this view, the center of a black hole is not an endpoint. It is a turning point, a place where the direction of the process changes from inward to outward. And this leads to a quietly remarkable possibility that what we perceive as a black hole from the outside may correspond from another perspective to the beginning of something new, an expanding region of space, a new universe, not separate, but connected, emerging from the same underlying structure, but unfolding in a different direction. If you follow this idea gently, without trying to fix it into a rigid picture, it begins to resemble something familiar. The idea of a beginning, that is not quite a beginning, a transition, rather than a creation from nothing. And suddenly, the concept of the Big Bang, the origin of our universe, begins to take on a new shape, not as a singular event that appeared from nowhere, but as the inner unfolding of a process that may have begun elsewhere, under conditions we cannot directly observe, and if that is true, then the journey inward, into a black hole, may be mirrored by a journey outward in another region of reality, a quiet symmetry, one side appearing as collapse, the other as expansion. Now, this is not something we can observe directly. The boundary we spoke of earlier, the event horizon, prevents any information from passing back outward in a way we could detect, so these ideas remain, for now, in the realm of careful speculation, grounded in mathematics, supported by certain patterns, but not yet confirmed through direct observation. And yet, they persist, because they offer something that the simpler picture does not. Continuity, a way of connecting what we know with what we do not yet understand, and perhaps more importantly, they offer a way of thinking about the universe that feels less like a closed story and more like an ongoing process, not a single beginning, followed by a single ending, but a sequence, a flow, where structures form, evolve, transform, and give rise to new structures, quietly, continuously, across scales we only begin to glimpse. And as you sit with this idea, you may begin to feel a subtle shift, from thinking of black holes as final destinations, to seeing them as part of a larger cycle, not places where things end, but places where something changes. And if that is the case, then the question we began with, the quiet possibility that our universe might exist within such a structure, no longer feels as distant. It becomes a natural extension of the same pattern, a possibility that does not demand belief, only curiosity. And from here, as the idea settles softly into place, we can begin to explore another layer of this mystery. Not what happens to matter, but what happens to information. Because if something passes through such a transformation, if it moves from one region of reality into another, does anything of it remain? Does anything persist? Or is it somehow rewritten? This question, simple on the surface, leads us into one of the deepest puzzles in modern physics, a puzzle that may reshape not only how we understand black holes, but how we understand reality itself. From this shift in perspective, where black holes begin to feel less like endings and more like transitions, another quiet question begins to rise. Not about matter, not about energy, but about something more subtle: information. At first, this word may seem abstract, but in physics, information has a very simple meaning. It is the detailed description of a system, the exact arrangement of particles, the position, the motion, the relationships between them. If you imagine a book, the ink on the page carries information. The order of the words, the structure of the sentences, all of it forms a pattern. Even if you were to scatter the pages or rearrange them, the information would still exist, though perhaps harder to read. In this sense, information is not something separate from the physical world. It is the pattern within it. And according to our best understanding of physics, information is not supposed to disappear. It can change form, it can become more difficult to access, but it is not lost. This principle has guided scientists for a long time. It suggests that the universe, at its deepest level, preserves the patterns that define it. And this is where black holes introduce a quiet mystery, because when something falls into a black hole, it seems from the outside to vanish. A star, a cloud of gas, even light itself, crosses the event horizon and no longer returns. If that were the whole story, it would suggest that the information describing those things has been erased, gone, not transformed, but removed entirely. And that creates a problem, because it would mean that one of the most fundamental principles we rely on, the preservation of information, does not hold in these extreme conditions. For a time, this was accepted as a possibility, that black holes might simply erase information, breaking the usual rules. But over the years, another idea began to take shape, one that suggested a different outcome. Instead of information being destroyed, it might be preserved in a way that is not immediately obvious. To understand this, it helps to return to the boundary we've been gently exploring, the event horizon. From the outside, it appears as a surface, a boundary beyond which we cannot see. But what if this boundary is not just a limit? What if it is also a kind of record? Imagine that as objects approach the event horizon, their information is not lost, but somehow encoded onto this boundary. Not in a literal, visible way, but in a deeper, more subtle form, like patterns pressed into a surface, too fine to see directly, but still present. In this view, the black hole does not erase information, it stores it, not in the volume inside, but on the surface itself, a quiet layer, holding the history of everything that has passed through. And over very long periods of time, black holes are not entirely silent. They emit a faint form of energy, a slow release that gradually reduces their mass. This process is extremely gentle, almost imperceptible on human timescales. But over vast stretches of time, it continues, and as this energy is released, some physicists suggest that the information stored on the surface may also be carried away in a transformed, encoded form, not lost, but dispersed. Like a message slowly fading into the background, its structure preserved, but difficult to reconstruct. This idea that black holes preserve information, even as they appear to hide it, is known as the information paradox, a puzzle that arises because two deeply trusted principles seem to conflict. On one side, the idea that information must be preserved. On the other, the behavior of black holes, which seem to conceal it completely. And yet, rather than choosing one over the other, many scientists now believe that both are true, that information is preserved, but in a way that challenges our intuition. And this leads to a quietly profound shift in perspective. Because if information is not destroyed, even in the most extreme environments, then the universe itself may be more like a vast system of patterns, continuously transforming, but never truly losing what it contains. Everything that happens, every interaction, every structure, leaves a trace, not always accessible, not always visible, but present. And in this sense, a black hole becomes something different from what we first imagined. Not a place where things disappear, but a place where information is hidden, encoded, and slowly transformed. A kind of memory, not conscious, not intentional, but real. And if we follow this idea just a little further, it begins to connect to something even more surprising. The possibility that the structure of reality itself may be deeply tied to information, that space, time, and matter may emerge from patterns rather than existing independently, and that what we perceive as a three-dimensional world may be a kind of projection arising from information stored on a deeper boundary. This idea may sound unusual at first, but like many of the concepts we've explored, it does not ask you to accept it immediately, only to consider it, to hold it gently alongside what you already know. Because as we move forward, we will begin to explore how this idea unfolds, how the surface of a black hole might relate to the structure of the universe itself, and how the boundary we cannot cross may hold more information than the space it encloses, a quiet suggestion that reality may not be what it seems at first glance. From here, something subtle begins to take shape. As the idea of information starts to unfold, a quiet shift in how we imagine the universe itself. Up until now, it has felt natural to think of reality as something that fills space, a three-dimensional world where objects have volume, where things exist within a kind of vast container. But what if that picture, while useful, is not the deepest one? What if the true structure of reality is not defined by what fills space, but by what exists at its boundaries? This idea begins with a simple observation. If information is preserved, even in a black hole, then it must be stored somewhere. And as we gently explored, one possibility is that this information is not hidden deep inside, but encoded on the surface, the event horizon. This leads to a surprising conclusion that the amount of information a black hole can contain is not determined by its volume, but by the size of its surface. In everyday experience, this feels counterintuitive. If you imagine a box, you would expect that a larger box with more space inside could hold more information. But in the case of a black hole, the relationship appears to be different. It is the area of the boundary, the surface itself, that determines how much information can be stored. And this idea, simple at first, begins to expand, because if it applies to black holes, could it apply more broadly? Could it be that our entire universe, with all its galaxies, stars and structures, is, in some sense, described by information encoded on a distant boundary? This is the essence of what is often called the holographic principle, a name that comes from a familiar kind of image, a hologram. If you've ever seen a holographic image, you may recall how a flat surface can appear to contain depth, a two-dimensional pattern, when illuminated in just the right way, reveals a three-dimensional scene. Not because the depth is physically there, but because the information describing that depth is encoded in a different form and in a similar way. This principle suggests that what we experience as a three-dimensional universe may arise from information stored on a two-dimensional boundary, not as an illusion, but as a different kind of description, a translation from one form into another. Now, this does not mean that the world around you is unreal. The chair you sit on, the air you breathe, the quiet rhythm of your heartbeat, all of it remains as real as it has always been. But it suggests that the underlying structure of reality may be more subtle than it appears, that what we perceive as space may not be fundamental. Instead, it may emerge from deeper patterns, from relationships encoded in a way we do not directly observe. This idea can feel abstract, but there is a gentle way to approach it. Imagine reading a story. The story itself unfolds in your mind, with characters, places, and events that feel vivid and real, but the entire story is encoded in something much simpler: words arranged on a page. The richness of the experience emerges from the structure of those words, not because the world of the story physically exists, but because the information describing it is organized in a meaningful way. In a similar sense, the universe may be like a story, not fictional, but structured, arising from patterns that, when interpreted in the right way, give rise to the experience of space, time, and matter, and the boundary, the surface, plays a central role in this, because it is where the information resides, where the patterns are encoded, and from which the deeper structure emerges. Now, if we return to black holes, this idea becomes even more intriguing, because the event horizon, that quiet boundary we've been circling around, may not just be a limit to observation. It may also be a kind of screen, a place where information is organized, stored, and possibly even projected. Not in the sense of an image cast onto a wall, but in the sense of a deeper correspondence, where what happens on the surface is connected to what appears within, and if that connection holds, then the interior of a black hole, the region we cannot directly observe, may be described entirely by what is happening on its boundary, a complete description encoded in a different form. And if such a relationship exists for black holes, it raises a gentle but profound question. Could the same be true for the universe as a whole? Could the vast expanse we experience, the depth of space, the flow of time, be in some way a projection of information encoded on a boundary we cannot see, a boundary that surrounds us, not in a visible sense, but as part of the deeper structure of reality? This idea does not claim certainty. It does not replace the familiar picture, but sits alongside it, offering another way to think, a complementary perspective, and like many of the ideas we have explored, it invites curiosity rather than conclusion. Because if reality is shaped by information, and if that information is stored on boundaries, then the distinction between inside and outside, between depth and surface, begins to soften. It becomes less about where things are, and more about how they are described, how they are encoded, and how those patterns give rise to the experience we call the universe. And as this idea gently unfolds, we begin to approach another boundary, not one defined by a black hole, but one that defines our entire ability to observe, because there are limits, not just to where we can go, but to what we can know. And it is at this edge, this quiet horizon of understanding, that the next part of our journey begins. There is another layer to consider, something even more subtle, as the idea of reality as a kind of surface begins to unfold, not what we can understand, but what we cannot. Because throughout this journey, there has been a quiet boundary present in every idea we have touched. Sometimes it appeared as the edge of a black hole, sometimes as the limits of our equations, and sometimes as the point where imagination begins to blur. This boundary is not just physical, it is also a limit of observation, a horizon of knowing. If you look up at the night sky, you might feel as though you're seeing into an endless expanse, stars scattered across a vast distance, galaxies stretching far beyond what the eye can resolve. But even this view, as wide as it feels, is limited. The light reaching you has travelled for a finite amount of time. It carries information from distant places, but only from the past. There is a horizon, beyond which light has not yet had time to arrive, a quiet boundary defining what you can see and what remains hidden. This is sometimes called the observable universe, not the entire universe, but the portion accessible to us through light, through signals, through the information that has had time to reach us. Beyond that boundary, there may be more galaxies, more structure, perhaps even entirely different regions, shaped by conditions we cannot directly detect. But for now, they remain beyond our reach, and in this way, our understanding is shaped not only by what exists, but by what we're able to observe. This pattern repeats itself when we return to black holes. The event horizon, as we have seen, is not a physical surface you could touch, but it acts as a boundary, a point beyond which information cannot return to us. From the outside, we can study the effects of a black hole. We can observe how stars move, how light bends, how energy is emitted near its edge. But we cannot see inside, not because there is nothing there, but because the structure of space and time does not allow that information to reach us. And so, once again, we are faced with a horizon, a limit, not of existence, but of access. Now this may seem like a restriction, but it also offers something important. It reminds us that our models of reality, our theories, our descriptions, are always built from the information available to us. They are not the universe itself. They are maps, carefully constructed, remarkably accurate in many ways, but still representations. And like all maps, they have edges, places where the detail fades, where the terrain becomes uncertain, and at those edges, new ideas begin to form, not as definitive answers, but as possibilities, carefully explored, gently tested, refined over time. The idea that our universe might exist within a black hole is one such possibility. It arises not from direct observation, but from patterns, from the way different pieces of our understanding begin to align, the behavior of space and time under extreme conditions, the preservation of information, the structure of boundaries, all pointing, not conclusively, but suggestively, toward a deeper connection. But we must hold this idea lightly, because there is a difference between what is known and what is inferred, between what has been observed and what has been reasoned, and both have their place. Now, as we reflect on these limits, something else begins to emerge, a sense that boundaries, horizons, are not just obstacles, they are also defining features. They shape what we can know, they guide how we explore, and in some cases, They may even contain more information than the regions they enclose. This idea, subtle at first, becomes more meaningful when we consider the universe as a whole. Because just as a black hole has an event horizon, the universe itself may have a kind of boundary, not a visible edge, but a limit defined by what can be observed and what cannot. And if that is true, then the universe is not an open, infinite stage in the way we might first imagine. It is structured, defined, in part, by its horizons. And this brings us to a quiet question. If our universe has a boundary, even an invisible one, then what lies beyond it? Not in a physical sense we could travel to, but in a conceptual sense. What lies beyond the limits of our observation, our models, our current understanding? Is there more structure, more layers, more regions of reality, connected in ways we're only beginning to glimpse? These questions do not demand immediate answers. They're not meant to be resolved in a single moment. Instead, they open a space for curiosity, for careful thought, for the slow unfolding of ideas that may take years, or even generations, to fully explore. And as we sit within that space, gently, without rushing, we can begin to shift our attention once more, from the limits of what we can observe, to the question of how everything began. Because if boundaries define what we can see, then the boundary of the universe itself may hold clues to its origin, and perhaps to its deeper structure. Was the beginning of the universe truly a beginning? Or was it, like the center of a black hole, a transition from something we cannot directly observe, a continuation rather than a starting point? As these questions begin to take shape, we move gently into the next part of our journey, one that explores the origin of the universe, not as a fixed moment, but as a process that may be connected to everything we have seen so far, a quiet unfolding that may link the smallest scales to the largest, in ways that are both subtle and deeply profound. With these boundaries quietly present in the background, we can begin to turn towards something long considered the beginning of everything, the origin of the universe. For many years, the story has been told in a familiar way, that the universe began as a single, incredibly dense state, and then expanded outward, space itself stretching, carrying galaxies along with it, gradually forming the vast structure we observe today. This event is known as the Big Bang, but despite its name, it was not an explosion in the way we might imagine. There was no central point in space where matter burst outward into emptiness. Instead, space itself was expanding, everywhere, all at once, a gentle stretching, not into something else, but of space itself. To picture this, you might imagine a soft surface, like the skin of a balloon. If you were to slowly inflate it, points on that surface would move away from each other, not because they're travelling across the surface, but because the surface itself is growing. In a similar way, galaxies move apart, not by flying through space in the usual sense, but because the space between them is slowly expanding. And if we follow this idea backward, gently reversing the process, we find that everything was once closer together, closer, denser, warmer, until we reach a point where our current descriptions begin to lose clarity, not because something dramatic necessarily happened, but because our tools for describing it become less precise. And here, something familiar begins to echo, the same quiet limitation we encountered when thinking about the center of a black hole, a place where our understanding softens, where equations no longer provide clear answers, where we sense that something deeper is present, but not yet fully described. Now, For a long time, this moment has been treated as a true beginning, a starting point, the first moment of time itself. But some scientists have begun to explore a different possibility, one that does not replace the Big Bang, but gently reframes it. What if this moment, this dense, early state of the universe, is not the beginning, but a transition, a continuation of something that came before? To explore this idea, it helps to think again about what we have seen inside black holes, the inward journey, the gradual compression of matter, the possibility that, at the deepest levels, this compression does not continue forever, but reaches a limit and then changes direction. A quiet rebound. Now imagine that what we call the Big Bang is not the start of expansion from nothing, but the outward phase of such a process, a release following an earlier compression, not visible to us, not directly observable, but part of a larger cycle. In this view, the universe does not begin in isolation. It emerges from conditions that may exist beyond our current horizon of observation. And this idea becomes even more interesting when we consider another feature of the early universe, a phase of very rapid expansion, so rapid that regions of space were carried apart faster than light would normally travel through them, not because anything was moving through space at impossible speeds, but because space itself was stretching, quickly, smoothly, evenly. This phase is often described as inflation, but rather than thinking of it as a technical process, you might imagine it as a moment when the surface of our balloon, instead of expanding slowly, suddenly grows more rapidly, smoothing out irregularities, spreading everything evenly, preparing the structure that will later evolve into galaxies and stars, and then, just as gently, this rapid expansion slows, the universe continues to grow, but at a calmer pace, and over time, structures begin to form, galaxies, stars, planets, life. But if we return to the deeper question, something remains quietly unresolved. What came before this expansion? If the early universe resembles the interior of a black hole, if it follows patterns similar to those we see in extreme gravitational environments, then perhaps the Big Bang is not an isolated event, but part of a larger structure, a continuation from a previous state that lies beyond what we can directly observe. This does not mean that we must abandon the familiar story, the expansion of the universe, the formation of structure, the evidence we observe all remain valid, but it suggests that the story may not be complete, that there may be a deeper layer connecting what we see to something beyond. And if that is the case, then the origin of the universe becomes less like a sudden beginning, and more like a transition, a passage from one phase of reality into another. And as we sit with this idea, gently, without needing to resolve it, another question begins to form. If the universe can emerge from such a process, if expansion can follow compression, then where might that compression come from? What kind of structure, what kind of environment could give rise to a universe like ours? This question leads us naturally to something we've already explored: black holes, not as isolated objects, but as potential starting points, seeds from which new regions of space and time might grow. And as this possibility begins to take shape, we can move one step further into a view of the cosmos that is not a single, isolated story, but a branching one, where universes may emerge, not alone, but as part of a larger unfolding pattern. If we follow this idea a little further, the universe itself begins to feel less like a fixed beginning and more like something that grows, a quiet possibility. If the early universe resembles an expansion that followed a deep compression, And if black holes represent regions where matter is drawn inward, shaped by extreme gravity, then it becomes natural to wonder, could these two processes be connected? Could what happens inside a black hole lead to the beginning of something else, not in a dramatic or explosive way, but in a way that unfolds quietly, naturally, as part of a larger pattern? Some scientists have explored a view in which black holes are not simply endpoints, but beginnings, places where matter does not disappear, but transitions into a new phase, a new region, a new universe. To approach this idea gently, it helps to think in terms of growth. Imagine planting a seed. At first, there is very little to see. The seed rests quietly, contained, compact. But within it, there is potential. Given the right conditions, it begins to change, not suddenly, but gradually. It absorbs energy, reorganizes itself, and eventually begins to expand outward, forming something new. In a similar way, a black hole can be imagined as a kind of cosmic seed. From the outside, it appears as a region where matter is being drawn inward, compressed, hidden from view. But from another perspective, from within the deeper structure of reality, that same process may correspond to the formation of a new expanding region, a universe. Not identical to our own, but shaped by the conditions from which it emerged. In this view, each black hole becomes a point of possibility, a place where new regions of space and time might unfold, not visible from the outside, but real in their own domain. And if this process occurs more than once, if black holes form in many different regions of the cosmos, then the picture begins to expand. The universe we see may not be the only one. It may be part of a larger collection, a branching structure, where new universes emerge from older ones, like leaves growing from a tree, each branch connected to its origin, but developing its own path, its own structure, its own history. Now this idea introduces something subtle but important. If universes emerge from black holes, then the properties of each new universe may depend on the conditions of the one before it, the amount of matter, the distribution of energy, even the fundamental relationships that govern how things interact. Each new universe may carry traces, echoes of its origin, not in a direct observable way, but in the underlying patterns that define its behavior. And over many such transitions, many generations, the structure of the cosmos may become more complex, more varied, more interconnected. This is not something we can observe directly. The boundaries between these regions, the transitions from one to another, remain beyond our current ability to detect. But the idea itself offers a way to think about the universe that is both continuous and evolving, not a single, isolated event, but a process that unfolds across scales we are only beginning to imagine. And as you sit with this image of universes emerging like branches, something else begins to shift, the sense of scale. Instead of thinking of the universe as the largest thing that exists, we begin to see it as part of something larger, not in a way that diminishes it, but in a way that places it within a broader context, a network of possibilities, a quiet unfolding of structure, where each region gives rise to others, through processes that are both subtle and profound. And within this larger picture, black holes take on a new role. They are no longer just features within a universe. They are connections, transitions, points where one region of reality may lead to another. And if that is the case, then the question we began with, the possibility that our universe exists inside such a structure, becomes more than just an abstract idea. It becomes part of a larger pattern, one that does not stand alone, but fits into a broader framework. a way of understanding the cosmos not as a single story, but as a collection of stories, gently linked together. And yet, even as this idea expands, it remains soft, unconfirmed, open, because we are still working at the edge of what can be known. We are following pattern, connections, suggestions, not certainties, and that is part of what makes this exploration meaningful. It invites us to consider possibilities without needing to fix them in place, to hold them lightly as we continue to move forward. And as we do, one question becomes quietly central. If universes can emerge from black holes, if new regions of space and time can grow from these seeds, then what does that say about the universe we are in? Could it be that our own universe is the result of such a process, not separate, not isolated, but born from the interior of something else, a black hole in another region of reality? And if that is true, then the boundary of our universe, the limit of what we can observe, may correspond to something we have already encountered, a horizon, not around a single object, but around everything we know. And from within that horizon, everything appears normal, consistent, complete, just as our own experience has always been. And as this idea gently comes into focus, we can take one more step toward understanding what it might mean to live inside such a structure, not as a distant possibility, but as a perspective that quietly reshapes how we see everything around us. As that image of black holes as seeds begins to settle in your mind, something quiet begins to shift. What once felt like a distant idea begins to move closer, not as a conclusion, but as a perspective. If black holes can give rise to new regions of space and time, if universes can emerge from deep compression followed by expansion, then it becomes natural to ask, could our universe be one of them? Not as a bold statement, not as something to accept or reject immediately, but as a possibility worth considering gently. To explore this idea, it helps to return to something familiar, the event horizon, that quiet boundary surrounding a black hole, beyond which information cannot return to an outside observer. From the outside, it appears as a limit, a surface that defines what can be seen and what remains hidden. But from the inside, that boundary is not something you would notice. There is no visible edge, no wall, no sudden transition. Everything continues as it always has. And this is where the idea becomes quietly intriguing, because our universe also has a boundary, not a physical edge you can travel to, but a limit defined by what we can observe, a horizon, beyond which light has not yet reached us, beyond which information remains inaccessible. From within this boundary, everything appears consistent. Space stretches, galaxies move, time flows. There is no sense that we are inside anything, no indication of an external structure, and yet, from another perspective, this entire region could be part of something larger, something we cannot directly see. In this way, the analogy begins to take shape. Just as the interior of a black hole appears normal to someone inside it, our universe may feel complete, self-contained from our point of view, even if, from another perspective, it is part of a deeper structure. Now, this does not mean that our universe behaves exactly like the interior of a black hole. The comparison is not exact, but there are similarities, patterns that align in subtle ways. For example, the early universe was extremely dense, much like the compressed state we associate with gravitational collapse. It then expanded, rapidly at first, and then more gradually, forming the structures we observe today. This sequence, compression followed by expansion, echoes the ideas we explored earlier, and when physicists study the mathematics of these situations, they sometimes find that the equations describing the interior of a black hole and those describing an expanding universe share certain features, not identical, but related, as though they are different expressions of a deeper pattern. Now, rather than focusing on the equations themselves, it is enough to understand the intuition that the same underlying principles, the same ways in which space and time can bend, stretch, and evolve, may give rise to both phenomena: a collapsing region seen from one side, an expanding universe seen from another. And if that is the case, then what we call the Big Bang may not be the beginning of everything, but the beginning of our region, our perspective, the point at which expansion became visible from within. And before that, there may have been a different phase, one we cannot observe directly because it lies beyond our horizon. In this view, the universe is not isolated, it is embedded, connected, through structures we cannot see, to a larger framework. And black holes become the bridges between these regions, not tunnels in the usual sense, not shortcuts through space, but transitions where one structure gives rise to another. Now, as you sit with this idea, it is important to hold it gently. It is not something we can confirm directly. There is no observation that definitively shows we're inside a black hole, but neither is there anything that fully rules it out. And, in science, possibilities that are consistent with what we know are worth exploring, not as final answers, but as ways of expanding our understanding, and perhaps, more importantly, as ways of shifting our perspective. Because if we imagine, even briefly, that our universe is part of something larger, that what we see is one region within a broader structure, then something changes, not in the physical world around us, but in how we relate to it. The universe becomes less like a closed container and more like a window, a view into a deeper, more layered reality, one where boundaries exist but are not absolute, where beginnings may be transitions, and where what feels complete may be part of something still unfolding, and yet, even within this possibility, everything remains as it is. The stars continue their slow movement, galaxies drift, time flows. From within, the experience does not change. And perhaps that is the most important part, that even if the structure of reality is deeper than we imagine, our place within it remains real, meaningful, present. And as this thought settles, softly, like a distant echo, we can allow ourselves to step back once more, to expand our view beyond a single universe, toward the possibility that many such regions may exist, connected not directly, but through patterns, through processes, through the quiet unfolding of the cosmos itself. As this view of our universe as just one region within something larger begins to take shape, your perspective starts to widen naturally, not abruptly, but slowly, like stepping back from a landscape and realizing it is part of something much larger. If one universe can emerge from a process connected to a black hole, then it is possible that this process is not unique, that it may happen again and again, in different regions, under different conditions, across a broader framework we're only beginning to imagine. This leads to a gentle but expansive idea that there may not be just one universe, but many, not necessarily arranged in a simple way, not lined up or stacked, but existing as separate regions, each with its own structure, its own history, its own unfolding story. This is often referred to as the multiverse, a word that can sound complex, but at its heart, It simply means a collection of multiple universes, each one complete in itself, each one governed by patterns that may be similar or slightly different. Now, there are many ways scientists have imagined such a structure. Some describe universes as bubbles, forming within a larger space, each bubble expanding, evolving, perhaps occasionally interacting, but mostly existing independently. You might picture something like droplets forming in a vast invisible medium, each one carrying its own internal structure. Others imagine a more connected framework, where black holes, those quiet transitions we have been exploring, act as links, not visible connections, not pathways we could travel through, but relationships, points where one region gives rise to another. In this view, the multiverse is not just a collection of separate spaces, it is a network, not tightly woven, not densely connected or a link through processes that repeat across scales. A black hole forms, matter compresses, a transition occurs, and a new region begins to expand. From the inside, it appears as a universe. From the outside, it is part of a larger pattern. And if this process continues, over long stretches of time, the structure becomes richer, more layered, more complex, a quiet web of regions, each connected through their origins, even if they remain separate in experience. Now, there is another idea that sometimes appears alongside this one, the possibility of shortcuts, or tunnels, connecting different regions of space, often called wormholes. These are hypothetical structures, solutions that arise in certain mathematical descriptions of gravity, where space bends in such a way that distant points become connected. But rather than imagining them as dramatic passages, it may be more helpful to think of them as possibilities, hints that space itself can be shaped in ways that allow unexpected relationships. Not necessarily pathways we could use, but indications that the geometry of reality is flexible, capable of forming connections that are not obvious from our everyday experience. And even if such structures exist, they may be rare, unstable, or simply beyond our current ability to observe. So we hold them lightly, as part of the broader landscape of ideas. Now, returning to the multiverse itself, something interesting begins to emerge. If each universe has its own conditions, its own patterns, then the diversity of possible structures becomes vast. Some universes may expand rapidly, others more slowly. Some may form galaxies and stars. Others may remain simple, or evolve in ways we cannot easily imagine. And within this variety, our universe becomes one example, not the only one, not necessarily the most typical, but one that has developed conditions that allow complexity, structure, and life to emerge. And this perspective does not diminish our universe. If anything, it adds depth, because it suggests that what we observe, the balance of forces, the formation of stars, the emergence of life, is part of a broader landscape of possibilities, a quiet unfolding of structure across many regions, each exploring a different path. And yet, even within this expanded view, something remains constant. The experience from within a universe is always local, contained, complete. From our perspective, we see galaxies, stars, the slow movement of cosmic time. We do not directly experience the existence of other universes. They do not intrude upon our daily awareness. And so, the multiverse remains, for now, a conceptual extension, a way of thinking about what might lie beyond our horizon. Not something we observe directly, but something that helps us frame the patterns we do see. And as this idea gently settles, another question begins to form. If universes can exist within a larger structure, And if they may be connected in subtle ways, then could they influence one another? Not through direct interaction, but through deeper relationships. Could something beyond our universe shape its behavior, even in ways we do not immediately recognize? This question leads us toward one of the most intriguing observations in modern cosmology: the expansion of the universe itself, a steady, ongoing stretching of space that appears to be accelerating, not slowing down as might be expected, but gradually increasing. And the cause of this behavior remains one of the most open questions we have. As we move gently into this next idea, we begin to explore the possibility that what lies beyond our universe may not be entirely separate, that it may, in subtle ways, be shaping the space we inhabit, even now. As the horizon of thought expands to include many possible universes, we can gently return to something we can observe: the expansion of our own universe. For a long time, it was expected that this expansion, set in motion in the early universe, would gradually slow down. Gravity, after all, pulls things together. Galaxies attract one another. Matter gathers. And so it seemed natural to imagine that, over immense stretches of time, the outward motion would ease, perhaps even reverse. But when astronomers began to look more carefully, measuring the light from distant galaxies, something unexpected appeared. The expansion was not slowing down, it was accelerating. Very gently, very gradually, but consistently. Galaxies were moving away from each other, faster over time, not because they were pushing through space, but because the space between them was stretching more rapidly. And this led to a quiet question. What is causing this? To describe this effect, scientists use the term dark energy, not because it is dark in the usual sense, but because its nature is not yet fully understood. It does not emit light, it does not interact in familiar ways, but its influence can be seen in the way space itself expands. Now, rather than thinking of dark energy as a substance, it may be more helpful to imagine it as a tendency, a gentle, persistent stretching, like a tide, slowly pulling everything apart, not forcefully, not dramatically, but steadily, over vast distances and long periods of time. And this brings us to a subtle possibility. If the universe is part of a larger structure, if it exists within a broader framework, then perhaps this expansion is not entirely self-contained. Perhaps it is influenced, in some way, by what lies beyond. This idea does not suggest a direct interaction, not in a way we could easily detect, but it opens the door to thinking of our universe not as isolated, but as part of a deeper system, one where regions of space, though separated by horizons, may still be connected through underlying structures. In some theoretical models, space itself may have more dimensions than we directly perceive, not in a visible sense, but as additional directions. Beyond the three we experience in everyday life, these extra dimensions, if they exist, may shape how gravity behaves, how space expands, how different regions of reality relate to one another. And in such a framework, it is possible that what we perceive as dark energy could be related to influences that extend beyond our observable universe, not as a force entering from outside, but as part of the geometry of a larger system, a subtle interaction woven into the structure of space itself. Now, this idea remains speculative. It is one of many ways scientists explore the question, but it offers something valuable, a way of connecting what we observe with what we do not yet fully understand. Because the acceleration of the universe is real, it has been measured, confirmed, studied in detail, but its cause remains open, and that openness allows for possibilities. Possibilities that extend beyond the familiar picture. If we imagine the universe as a region within a larger structure, then its expansion may be influenced by the shape of that structure, by the way it connects to other regions, by the deeper geometry that defines how space itself behaves. And in this view, dark energy becomes less like an isolated mystery and more like a clue, a hint that the universe may not be entirely self-contained, that there may be more, beyond what we can directly observe. Now, as you sit with this idea, it is important to hold it gently, not as a conclusion, but as a perspective, because science often progresses by exploring possibilities, by considering different ways of understanding the same observations, and over time, through careful study, some ideas become clearer, more supported, while others fade. But in this moment, what matters is the sense of connection, that what we observe, even something as subtle as the slow acceleration of space, may be linked to a larger framework, one that includes not just our universe, but others, one that may extend beyond the boundaries we can see. And yet, even within this vast picture, the experience from within remains unchanged. The stars still move slowly across the sky, galaxies drift, time flows. From where we are, everything feels complete, and perhaps that is part of the beauty of it, that even if the universe is part of something larger, something deeper, something more connected, our place within it remains steady, grounded, present. And as this thought gently settles, we can allow ourselves to move toward a quiet closing, not to resolve every question, but to reflect on the journey we have taken, from black holes to galaxies to the structure of reality itself, a journey that does not end with certainty, but with something softer, a sense of wonder held gently at the edge of understanding. As the vastness of these ideas begins to settle, we can gently return, not to a single answer, but to a quiet place, where everything we have explored can simply rest. Over the course of this journey, we have moved slowly, from something small and distant to something wide and deeply connected. We began with black holes, quiet regions of space, where gravity bends reality so deeply that even light cannot escape. At first, they may have seemed like isolated objects, strange, and perhaps a little unsettling, but as we looked more closely, their role began to change. We saw how they sit at the centers of galaxies, shaping the motion of stars, guiding the flow of gas and dust, quietly influencing the formation of new worlds. We followed the life of galaxies through their brighter phases, when their centers shine intensely, and through their quieter moments, when balance begins to emerge. We traced the journey of dust, from the fading remnants of stars to the slow birth of new ones, and eventually to the formation of planets and life. And through all of this, black holes remained present, not as interruptions, but as participants. Then, gently, we moved closer, not physically, but imaginatively. We explored what it might feel like to drift toward one of these regions, to approach a boundary where time slows, where space curves, and where familiar ideas begin to soften. We saw how different perspectives can coexist, how time can appear to stretch, or remain steady, depending on where you are, how the inward direction within a black hole may become something like a path through time itself. And as we continued inward, we reached the limits of our current understanding, a place where the equations we rely on begin to lose their clarity, where the idea of a singular point gives way to the possibility of something more subtle, a transformation, a transition, not an end, but a change in direction. From there, we turn to information, the patterns that define everything we see, and we found that even in the most extreme environments, information may not be lost, only hidden, encoded on boundaries, like the surface of a black hole. And this led us to a deeper idea, that the universe itself may be described not only by what fills space, but by the information that defines it. That what we experience as a three-dimensional world may emerge from patterns stored in ways we do not directly perceive. We explored the limits of observation, the horizons that define what we can see and what remains beyond our reach. And we allowed ourselves to consider the possibility that these limits are not just restrictions, but features, clues to the deeper structure of reality. From there, the view expanded once more. We reimagined the beginning of the universe, not as an isolated moment, but as part of a process, a transition, perhaps connected to the same kinds of structures we see in black holes. We considered the idea that black holes might give rise to new universes, that the cosmos may be more like a branching structure than a single, self-contained system. And finally, we widened the view even further, to a landscape where multiple universes may exist, each with its own unfolding story, gently connected through deeper patterns. We explored the quiet expansion of our own universe, and the possibility that its behavior may be influenced by something beyond what we can directly observe. And now, here we are, at the edge of understanding, not at a conclusion, but at a boundary, a place where knowledge meets uncertainty, where what we know blends softly into what we do not yet know. And perhaps this is exactly where we are meant to be, because science, at its heart, is not only about answers, it is about exploration, about following patterns, asking questions, and slowly expanding the horizon of what we understand. And sometimes, the most meaningful part of that journey is not the answers themselves, but the perspective we gain along the way. The realization that the universe is not a fixed, simple structure, but something layered, something evolving, something that reveals more the deeper we look. And yet, even with all of this, the quiet complexity, the vast connections, the unanswered questions, your experience remains simple. You're here, in this moment, breathing, aware, surrounded by a universe that, whatever its deeper structure may be, continues to unfold around you, just as it always has. And there is something comforting in that even as we explore ideas that stretch far beyond our everyday experience, the present moment remains steady, grounded, real. And so, as this journey gently comes to a close, you do not need to resolve every question. You do not need to decide which ideas are true or final. It is enough to let them drift, to allow them to settle softly, like distant echoes, because the universe, in all its depth, does not ask for certainty, only curiosity, and perhaps a quiet sense of wonder. And so, we've reached the end of tonight's exploration. Whether your eyes are still open, or you're already floating somewhere between waking and dreaming, thank you for being part of this little journey. If you'd like to join me again for more gentle wanderings, you're always welcome to subscribe or share this with someone who could use a peaceful pause. Time has a way of slipping through our fingers, but here, in this quiet moment, it's just you and the soft hush of rest. Sleep peacefully, wherever and whenever you may be.